James Webb's new galactic evolution discovery. The vastness of the universe has always captivated humans, with innumerable mysteries concealed in its depths waiting to be discovered. The James Webb Space Telescope has taken on the responsibility of solving these mysteries, and has lately made an astonishing finding that has stunned the scientific community. The telescope discovered not one, not two, but 6 huge galaxies that had existed since the universe's first billion years. These galaxies are unlike any we've seen previously, with billions of stars that appear more mature than their age would suggest. Everyone is wondering how these monster galaxies grew so large so soon. With this discovery, the James Webb Space Telescope has truly excelled itself, and we are eager to delve deeper into the complexities of these gigantic galaxies and the cosmic web that plays such a vital part in their development. Previous galactic evolution theories. Did we ever expect to observe enormous galaxies so soon after the Big Bang? Certainly not. When the universe first came into being, it was filled with hot gases and dark matter. These gases began to cool and clump together over time, forming the earliest galaxies. We thought these early galaxies were small and didn't have many stars. However, they fused with other galaxies and grew larger through time, eventually forming the gigantic galaxies we see today. At least, that's what we believed. Sometimes galaxies collide and merge, much like two families joining to make a larger one. These collisions can be violent and chaotic, with stars and gas flying everywhere. Scientists used to believe that galactic collisions were the primary means through which galaxies expanded and evolved over time. They assumed that the more collisions a galaxy had, the larger and more complicated it became. 6 huge galaxies developed within the first billion years of the universe's existence, according to the James Webb Space Telescope. These galaxies are huge, with billions of stars, and remarkably mature for their age. They're providing us with incredible new insights into the universe's creation. They are showing us how enormous galaxies might develop so fast after the Big Bang. Not so insignificant, is it? New galactic evolution theory. So, how do these big galaxies form so quickly? It turns out that they can do so by connecting to the cosmic web. What exactly is it? The cosmic web, like any other web, is a network of dark matter and gas that pervades the cosmos. The dark matter in the web's gravity draws gas, forcing it to collapse and create structures. These structures eventually evolve into enormous galaxies, with dark matter acting as a framework for the galaxy to build around it. The gas that falls into the galaxy is abundant in hydrogen and helium, the primary building components of stars. As the gas collapses, it begins to heat up, causing nuclear fusion processes that result in the formation of new stars. These stars fuse and generate even larger ones over time, eventually leading to the construction of huge galaxies containing billions of stars. It resembles a spider web, with galaxies serving as nodes. Returning to our galaxy, these 6 gigantic discoveries are linked to the cosmic web by tendrils, which are straw-like formations that suck in matter. These tendrils are part of a mechanism that permits galaxies to grow so quickly, and this current study may have just validated one of these mechanisms. The Atacama Large Millimeter Array, ALMA, in Chile was utilized to analyze one of these giant galaxies and its tendril. ALMA detects galaxy tendrils using spectroscopy, a technique that allows astronomers to examine the chemical composition and mobility of gas in space. The tendrils are formed of cold, dense gas that is being drawn towards a galaxy by the force of gravity. When this gas interacts with the hot, ionized gas in the galaxy, it produces a spectral signature that ALMA can detect. Its detectors can detect millimeter and submillimeter wavelengths emitted by the cold gas in the tendrils. When this gas absorbs or emits radiation at these wavelengths, it leaves a specific trace that ALMA's antennas can detect. Astronomers may use this technique to map the distribution and migration of gas in and around galaxies, including the tendrils that are being drawn into them. Astronomers can learn about the processes that drive galaxy formation and evolution by analyzing the features of these gas formations. ALMA can utilize imaging techniques, in addition to spectroscopy, to build detailed photographs of the tendrils and galaxies with which they interact. The structure and composition of the gas in the tendrils, as well as the shape of the galaxies themselves, can be revealed by these photos. They discovered that the tendril was attracting massive amounts of gas, which would eventually become new stars. This discovery is significant because it demonstrates that the cosmic web had a crucial role in the genesis of the universe. It is allowing galaxies to develop and evolve in ways that we previously did not understand. But now comes the really thrilling part. The researchers also discovered evidence that the tendril is connected to the cosmic web. This is a massive network of interconnected, invisible filaments that spans the entire universe. These filaments are assumed to be responsible for connecting galaxies and shaping the large-scale structure of the universe. The discovery of this tendril provides some of the first direct evidence that the cosmic web is a real physical structure that can be examined and analyzed, rather than a theoretical concept. It also sheds new light on how galaxies form and evolve throughout time. Study of a specific case. A team of astronomers led by Nicolas Bouch of the Astrophysics Institute of Paris completed one investigation that offers light on this process. The study, published in the journal Nature in 2013, employed the Atacama Large Millimeter a Submillimeter Array, ALMA, in Chile to observe BRI 1335-0417, a distant galaxy. BRI 1335-0417 is a submillimeter galaxy, which means that it emits the majority of its light in the submillimeter range of the electromagnetic spectrum. These galaxies are exceedingly distant and look as faint smudges in the sky, yet they are also among the universe's fastest star-forming structures. Bouch and his colleagues were able to investigate the gas around and around BRI 1335-0417 in unprecedented detail thanks to ALMA. They observed that the galaxy was surrounded by a massive halo of gas stretching for tens of thousands of light-years. This halo was supplied by tendrils of gas moving along the cosmic web, which were funneling matter into the galaxy and accelerating star formation. These straw-like structures of gas streaming through the cosmic web are assumed to be remains of the primordial gas that flooded the cosmos after the Big Bang. This gas gradually clumped together under the influence of gravity as the universe expanded and cooled, eventually producing the cosmic web we see today. When a tendril of gas collides with a galaxy, it can cause the production of new stars by supplying the raw element required for star formation. In the case of BRI 1335-0417, the tendrils were directing gas into the galaxy at a rate of around 100 solar masses per year, fueling the galaxy's rapid star production. Gas tendrils are also important in regulating the expansion of galaxies. As the gas flows into the galaxy, it can cause new stars to form, but it can also cause enormous outflows of gas and dust, which can inhibit further star formation. These outflows can be so intense that they completely evacuate gas from the galaxy, slowing its growth and keeping it from growing too huge. So, what does this all imply for our knowledge of the universe? It shows that the cosmic web may play a considerably larger role in galaxies' origin and evolution than previously imagined. It also opens up new paths for investigating the early universe and the processes that formed it over billions of years. But, perhaps most importantly, it reminds us of the universe's amazing beauty and complexity, as well as the significance of continuing to study and understand it. We can't help but be amazed by the universe, magnificent and inspired to unravel its many secrets as we continue to study and learn about it. Alright everyone, here is where the video ends. Thanks for watching.